All right, let's get started. Good morning, good afternoon, good evening, wherever you are viewing this video from. Let's get started. Okay, we'll get to a new case. We're starting a new case today. Let's get started. Let's click new case. It's loading. All right, so we'll be approaching the iSpend simulation environment, and we'll be starting with the fundamentals, some parameters you have to define before you can start your operation or your model fully. Okay, at the end of this section, you'll be able to enter necessary element to fully define a fluid package, specify required parameters in order to execute flash calculations, and fully define material stream, modify and set desired unit of measure, and review your stream analysis option. So we'll be getting started. The first thing you will encounter is the property environment. This is a property environment. This is a property environment. So the first thing you see is component list, fluid package, petroleum assay, reactions, common component, user property. So we'll be defining the fluid package, the component list. The component list file is .cml. The fluid package file is .fpk. Now the reason why they have their file is so you can import it or export it in your cases on your model. There's some model you'll be simulating. You don't need to start entering the various composition again if you have your already existing component list. So you just call it in by importing it. Then when if you want to save a component list, you can save it and export it and give it a name. It will save it .cml. Then the same thing with the fluid package, we save as .fpk. Maybe you want to save the fluid package as gas plant. It will save as gasplant.fpk. It's the FPK file, it's a fluid package file. So we'll be specifying the component list. When you click the component list, now is before we simulate, we have feed components. Our feed comprise on component list, different constituents, different composition, different components. Maybe if it's a natural gas feed, we might have the methane, we might have the ethane, we might have the propane, we might have CO2, we might have H2O if there's some amount of water in the natural gas stream. So these are defined as component lists. These are defined as our component list. So you cannot just start simulating. No, you have to define some of these component lists. Then after we have now there are some for cases where the component you are looking for is not in iSpend data bank. It's not in iSpend database. You can define your component knowing the normal boiling point, knowing the liquid density, knowing the molecular weight. You can define the component as hypothetical component. So you don't need to be afraid if your component is not in ICES databank. So, or in ICES database. Now, in component list, the default database is ICES database. We have two databases in the component list, which you can define your component list for. We have the ICES database and the iSpend properties database. But the default database is in ICES database. So once we declare hard, is originally telling us that it's ICES database that is being added. Then we have the component. Okay, we have the fluid package. The fluid package has its own databases. So fluid package, these are the thermodynamics parameters that we need to define in order to solve. For liquid, we have thermodynamic properties we can use to solve liquid flow. For gaseous flow, we have thermodynamic. For acid gas treatment or recovery, we have thermodynamic properties or equation of state we can use to solve this model. So depending on what the process, I mean the service you are modeling. Is it a gas, is it a liquid, is it a mixed fluid or mixed phase, gaseous or liquid? This is it acid gas treatment? This is what determines what thermodynamic equation of states you'll be using. So now in fluid package, we have three databases or three data banks. We have the ICES data bank or database. We have the iSpend properties database. Then we have the composition thermodynamic database or ComThermo database. So you can see that the fluid package has a step forward, while the component list has just two, this first two. The fluid package has a step forward with ComThermo. So, but the default also in fluid package is ICES data bank. Also in ICES, we have the method assistance. In ICES, we have the method assistance, and also in ICES, we have the help selection button. If you need any assistance, you can come to the help selection button, which is this. So anything you don't know, you can click here. It will take you to another page where you can understand some of these things. This is a component list. So we are on the component list. It will tell you everything about component list. So when you are doing your research, when you are doing your personal study, you can take your time and come through this ICE's help menu, and you understand in depth all the component list, and many of the things I'll be telling you today in course of this training are inside of this help. We have every necessary information you'll be needing. So this is the place you come to get all the parameters there defined. Then also for the fluid package, for midstream oil and gas / hydrocarbon processing. Let me click. So these are the various properties. This Penn-Robinson, this PSROV, this saltwater, this SRK2, SUSIM for sulfur recovery. We have acid gas. We have 4 levels of acid gas properties. We have the caustic wash. We have the liquid treating. We have the component solvent. We have the physical solvent. So when you want to understand what condition you will be using the acid gas wash, come to help. So you're seeing the various fluid components that are defined here. So when you come to the liquid, so if you want to use the liquid treatment properties available to model acid gas removal from LPG, liquefied petroleum gas, LNG, NGL, since the main hydrocarbon component are ethane, propane, and the typical process operates at low temperature and high pressure, a special thermodynamic package is required to properly model the liquid-liquid equilibrium involved. So the acid gas chemical solvent package is used here, but with binary and electrolyte pair parameter optimized for liquid-liquid applications. So this, from here you get the various reasons why you are using the liquid treating package for acid gas. Then all the components that are required are also defined here. You must add the following component to your case in order to add the acid gas liquid treating property package. At least one supported amine or amine blend. CO2 must be involved, H2S, H2, then supported component you can see, mercaptan, cyclohexane. These are all the supported components. So maybe any component that is not supported and you had, it will show you error or inconsistency. So you have to undergo some of this understanding so you can appreciate what you are using the fluid package. For midstream oil and gas hydrocarbon processing, Penn-Robinson and other cubic equation of states property packages are appropriate. Look at Penn-Robinson. When it comes to oil and gas operation, Penn-Robinson mostly are used. Glycol package of Penn-Robinson are recommended for dehydration of wet gas. Look at glycol package. For wet gas, it is recommended of Penn-Robinson. Then SAW Penn-Robinson and SAW SRK are used for saltwater system at low pressure. Saltwater, SRK, SRK, they are used for saltwater system at low pressure. So we have to understand this. Then for downstream hydrocarbon refinery system, we have what is also used. We have the Schausieder, Penn-Robinson, and SOV SRK, which is SOV Redlich Long, are generally used for atmospheric applications. SRK. This is SRK. This is SRK. Then Schausieder. These are the components, the fluid packages. So move to the next. So after defining, so from the material I will give to you, you see the various types of fluid package and the various types of systems, so you appreciate it better. So this is the property package selection. When you are doing ethylene glycol dehydration, these are the various components recommended. So with this table, you will not find difficult. So just look for the system you are doing. What are you simulating? What system are you modeling? So from which you have suggested fluid property package. And also, if you come to this help, if you come to the method assistance or the IC's help, you also appreciate. I'll show you the various fluid package methods and for their various applications. When you click method assistant, it will also bring you to this place. Just like the help button, the method assistant will also bring you to this place, so you can define, you can study and understand the processes you are doing and get a better understanding. So we'll be moving to the next thing, adding a stream. We'll move to the next, we'll move to the workshop, the first application, so I can explain some other fundamentals to you. Adding material stream. So before we can go to the simulation environment, you must first of all define all of this. Define your component list. Now, you can't define your fluid package on an empty component list. It will always show red. It can't show you green, or it won't converge. It won't converge. Convergence will mean every parameter is properly entered. The word convergence will be used often in high-spent ICs. When your streams are properly defined, it is regarded as it has converged or it has reached convergence. That means all the parameters, all the things you are required to specify are fully specified and they are specified rightly. So the red will change from yellow to green. So it's an indication that you are consistent with what you are doing. So if you want to add your material stream, okay, if you want to add your material stream, all of those will also define when we move to the simulation environment. Then we'll also talk about the SI unit, or the unit of measure. So in process simulation, you have to be very sensitive with the unit. You have to be consistent with the unit of measure you are using. You have to be consistent. If you are using SI units, you have to be consistent. If you are using EOSI, if you are using safety engineering, if you are using safety SI, all of those need to be defined. But also, you can also manipulate any of the unit and define it depending on your project. Okay, this is the unit you are using for this project. This is what you are doing for this project. So you appreciate it better. Also, we can also do, after adding our streams, we can also do stream analysis. Let's get to, mostly if you have not defined this environment, you can't get to this place. So let me quickly just define something so you can appreciate it. So let me just define methane. Let me come to fluid package. Let me choose Penn-Robinson. Okay, I've chosen Penn-Robinson. It has converged. So once it converged, I'm ready to move to my next environment. Now this component list one you are seeing, the first component list I created is the one that involved the methane. I can create as many component lists. Then also this component list, I can rename it. Gas. Then my fluid package, I can rename it too. Gas fluid package. FP. So you are not limited. So you can choose to leave it, you can choose to. So once I define it, I can also class it like this. I can save it. If I want to save it, I'll import it. When I click it, I'll export it and save it in my system. So, but in course of the workshop aspects, I'll explain it better. So I want to move to the simulation. That's why I'm just defining this quickly so that you can appreciate it. So move to our simulation environment. When we switch to our simulation environment, you are now at the model. This is the model. These are flow sheets. These are flow sheets. So this is the palette. You can move it. You can place it anywhere. You can dock it to our model. So this is the model palette. It houses all the equipment in iSPEN ISIS. All the equipment. Dynamic control, standard model, heat transfer models, manipulator models, pipe hydraulics, pressure changers, reactor, separators, including distillation columns and the likes. All of them, in case you are looking for any of a parameter, you can search for this separator. You can see separator here. This is a separator. This is a three-phase separator. These are all different levels of separator. If in case you want to look for a column, a boiler column, just type column. You see different types of column. And once you come on anyone, their name will show. So depending on what you want, if you are looking for reflux absorber, just keep moving. You see reflux absorber. This is a reflux absorber. This is an absorber. This is a refining shortcut column. This is a reboiled absorber. So the stripper is 4 stripper code, depending on what you are looking for. So you can search it and do it to clean it in case you want to look for some other component. So you don't think that is not available. So we can dock this. You can place it here and dock, or you can place it here and dock. So now we are here. You can see we can add stream. We can add stream. We can add stream from here. You can also add stream. All right. So if you want to add your stream, you can add stream from here. We have different types of stream. We have the material stream. We have the energy stream. Now, in our latest version of iSPEN ISIS, we now have the power stream. So we can distinguish between the material stream now, energy stream, and power stream, which is electrical stream. So this is the material stream. You can add it from here. Once you bring the material stream, we have color coding. This color, this is a royal blue. This is a royal blue. So once your string is under specified, it becomes like this. It's royal blue. But once we've specified this string and it converges, it will change color